is really important and everything, so I put, bibliography, I put my references up here. And that'll work for you too. If you guys want to do some research later, feel free to hit these sites. Specifically, the program that I worked on most is the OSRVT program, which is the One System Remote Video Terminal. And that's an add-on piece to the full system that really allows the mobile fighter to get the video and telemetry while they're actually in theater. And so what you can see here is they would get the information to them through the radios and through the comm system, but everything's through that laptop right there. And that's a Panasonic Toughbook. It's just rugged for military activity. And then you can see even in a mobile vehicle, kind of the same scenario. And one of the really cool things we started doing when I was actually leaving was what we called manned-unmanned teaming. So we would put our equipment in this helicopter right here. That's a Kiowa Warrior. And they would be able to receive the same video and data from the bird that the folks can get on the ground through that system. So if we needed target acquisition or we needed to actually throw a kill switch, we'd be able to give them eyes on target without them being in the area, and they could fire a missile from 100 miles away. So it was really important for us to reduce the risk of loss of life in the field, and that was one of the big success stories that we had doing that. This is just what we call ConOps, or concepts of operation. This is operationally how an unmanned system works in the field. So we kind of talked through this before a little bit, but you have the bird that's in the air looking at the target range, the theater, and then you have the ground system that's receiving a lot of the same data. Again, that same data could go to a helicopter for manned-unmanned teaming, or that could go to the soldier on the ground to get eyes on target. Payload. So this goes back to kind of what I was saying with commercial drones or the quadcopters or even the recreational vehicles. The payload is the most important part of this system because it's what's going to allow you to either exploit or actually execute, you're actually completing the operation. So the vehicle is just the vehicle. And these payloads are made to kind of snap in, plug and play, so you can build a lot of different capabilities and just kind of slap them onto the bird. So that was our POP 300. It's made in Israel, and it does all of our electro, optical, and infrared imaging and video, as well as laser target designation. Sorry, mouse right here. And then there's a lot of communication payloads. So if you're in an area where you can't get comms, it's a mountainous region like Afghanistan, what they'll do is they'll send out one of these unmanned aircraft vehicles with a comms relay, and that'll give the soldiers the ability to have communications where they might not have communications before. Really important for the soldier. And when we talk about communications and when we talk about securing ISR capabilities, the ComSec modules in these systems, which are classified, it's all government equipment, and the government provides them to the contractor that builds the systems. When we talk about security, we talk about cryptographic security, transmission security, emissions, and physical security. All really important. The biggest one being physical and emissions, because the biggest threat to these systems, they're probably not breaking the encryption. They don't necessarily have the technology or the knowledge. The government's working 24/7 with lots more resources to be able to control that. Transmission, most likely, is not going to get hijacked because of the encryption. But the emissions and the physical security, so you can think about being in theater and being there and having the systems. Obviously, you can just go hijack a ground control station or hijack the terminal. But the emissions piece is interesting because when you hear about like electromagnetic pulses or ways to disturb the frequency, jamming the frequencies, these are things that actually do happen in the field. Every piece of equipment, all these cables and wires give off some sort of signal, some sort of radiation, something that emits from this wire, and that can be exploited. So the real objectives here is to prevent loss of life, obviously, prevent risk, low cost, and the Army calls the unmanned system the eyes of the Army because it really is the eye in the sky, if you will. I don't know if anybody's seen that movie, Eye in the Sky. It's actually pretty good. So when we talk about intelligence, surveillance, and reconnaissance, Intelligence is sort of a piece of surveillance and reconnaissance. So you can think of surveillance as, actually for a period of time watching an area, watching a group of people, and pulling the information of whether that's, data from a telephone, mobile call, or actually video and imagery of where the people are. Reconnaissance is really a check in time of what's going on in a specific situation. And then intelligence is taking all of that data and having an analyst make some sort of decision on what's really happening and what the actions are going to be. So that makes it actionable. That's what's really important in terms of intelligence. Securing capabilities, so we talked about some of this. Encryption, the ComSec equipment, constant frequency hopping, so when you are transmitting data, that it's constantly switching on different frequencies, so it's hard to catch. The physical devices, so you've got firewalls, routers, switches, intrusion prevention systems, intrusion detection systems. And then this is a big piece, detection of emission vulnerabilities and mitigation, so making sure that they can't jam your signal, making sure that they can't send some kind of electromagnetic pulse and shut down the entire system. So the emission detection devices are really, really, really important. Exploitation, so outside of just getting video, images, telemetry.
Can I ask you a question about that?
Sure.
Emission detecting devices?
Yes.
So the idea is it senses that there's going to be some sort of pulse?
Yes.
So how does it affect they have to shut down to prevent that? Does it have the same effect? You guys see where I'm going with that?
Yeah, no, I see what you're saying. I'm not 100% familiar with the detection systems, but from what I understand is that the devices that send out those pulses are engineered in a certain way where there's factors that you can look for in the area to know that there's a device out there. But I'm not familiar.
Okay. Thank you.
Yeah, no worries. So outside of images and video and GPS information, there are payloads that are strapped onto these vehicles that can actually exploit specific devices that are in the area. So if you think about, mobile phones, they can send out a payload if they have the right intelligence to be able to pick up mobile signals, text messaging, basically anything that can happen on a mobile phone. They can do network intrusion, live network intrusion, GPS tracking obviously, and targeting. They're getting so sophisticated that they have these devices that can propel aerosol that is microscopic, that will tag an actual human so that you can infrared track them as they move about in a certain area, which is actually really cool stuff. Kind of scary. Vulnerabilities. So again, information security is important stuff. Human error, obviously, always a factor. 9 out of 10 crashes, human error. Interrupted comms, we talked about that with electronic warfare. It's important to make sure your communications aren't jammed. OEM software and hardware. So these vehicles, and Mo knows this, doing information assurance, that these vehicles are outfitted with Cisco products, Microsoft products, Red Hat, Linux, and if these systems aren't patched, aren't secured, aren't up to date, they are as vulnerable in the field as they are in a network in a corporation, at your house. Same with PCs. A lot of them are sitting on Windows, and if you miss Patch Tuesday and you got a vulnerability in there and they know how to exploit it, it's not good. There are checks and balances that you hopefully don't get there, but it's always a possibility if you're not making sure everything's up to date. And then again, you have that physical hijacking of the equipment. Always is a possibility. So I think this is the important part. So we talked about drones in the world of military and army, but as drones come more and more popular in civilian life, hobbies, news, sporting events, photography, videography, films, even in Baltimore during the unrest, outside of the FBI flying drones around, there were people that were flying drones around to see what was going on, to make sure that it was safer, to make sure, just to see what was happening. So as you can see in the future, shipping and logistics, Amazon, emergency response. So if there's a natural disaster, an earthquake, and it's not safe to go into a certain area, send in a robot. It's not gonna, if it breaks, big deal, we lost $1 million or whatever. Somebody might be upset about that, I wouldn't, but whatever. Private security, so if you own a large part of property, or this university, Defense contracting, rather, again, getting more of a sphere of reference of what's happening in your environment, what potentially could go wrong, sensing when things go wrong, if there are people places that are not supposed to be, then trip an alarm, rather than something physical on site. So the same vulnerabilities and exploitations are there for us in the civilian world. So let's talk about that. So let's talk about the payloads, right? You have HD, full 1080p, probably pretty soon 4K, video and images that can be taken by these birds. And it's, peeking in your window, seeing when you go to work, seeing if you are home or not home, so maybe a burglary could happen. There are people that are using these devices to exploit people in everyday life, and criminals that will use these in the future, probably for bad things. So it's something to think about as you guys go into the cybersecurity field, that this is going to become probably a pretty popular field of study in terms of how they're being used to exploit and how vulnerable they can be. So when you think about it, this guy right here, so this is a Raspberry Pi or a Beagle box. They're very small, cheap, 99 bucks mostly. Computers, full-on computers. You can stick Windows on there, you can stick Linux in there. But what people are doing is they're taking versions, pre-packaged versions of Linux that have penetration tools on them, network cracking tools, password cracking tools, and they're sticking remote access on there. So they're flying the drone out. They're putting it in an area where they want to exploit a network. They want to crack somebody's password, crack somebody's Wi-Fi, and then use their Wi-Fi because they're doing something illegal. And it's extremely simple, rather than trying to pinpoint and find someone's network and then do the intrusion remotely. You can be physically on their network,